All right, so we're going to hopefully finish up 6.5 today. Okay, we'll see if we don't get through it all. We might have to do a little tomorrow, but we might get through it all. So one thing we're going to look at in this section first is what it means to solve a triangle. So we've been writing down the trig functions of angles, sine, cosine, tangent, secant, cosecant, cotangent. Now what we're going to do is actually use that information to figure out how big are all the angles and all the sides in a triangle. So there's 6 things we have to find when you're solving a triangle. All the sides and all the angles. But you have to be given some of those pieces of information when you start the problem. So out of the 6 things that you have to find, one of them is going to be automatic every time, because we're solving right triangles. So every problem we do is going to have a 90-degree angle. So we already have that. So now we're down to 5 things you have to find. I have to give you, besides the 90, I have to give you 2 other pieces of information. And there's 2 types of problems that we could have. In addition to knowing that there's a 90, I have to either give you one of the other angles and one of the other sides, or I could give you 2 sides. So out of the 6 things you have to find, 3 of them are already going to be given to you, the right angle, and then 2 other pieces of information. Depending on which case you have, case 1 or case 2, it's going to change a little bit about how you have to solve it. So a couple things to keep in mind as we solve triangles. All the angles in a triangle have to add up to 180, so that's an important piece of information. And the Pythagorean Theorem is something that may come up as well. So we're going to just take a look at an example. We're going to do case 1 first. I'll give you an angle and a side, and you're going to have to figure out everything else in the triangle. So when we have to do a problem like this, you're going to be given information. Okay, just written out. A equals 2. B equals 6. They'll tell you information. What do you think would make all of that information that they're going to give you easier to visualize? What do you think we should do right away? It's going to also help us to figure out what's opposite and what's adjacent. Yep?
Draw it out.
Yeah, we're going to make a sketch. Okay, that's the first thing we want to do. Make a sketch. And then what we'll do is we'll make a table to organize all our answers. So a nice spot where I can easily see what did you get for all your values. Today, we're only going to use one of 3 trig functions: sine, cosine, or tangent. We're not going to use secant, cosecant, or cotangent. Anyone have a guess why we're not going to use those 3? Anyone have a guess now why we're not going to use those 3? Yep?
Because we don't have it on the calculator.
We don't have those ones on the calculator. Okay, to do them on the calculator, that's where we have to take one of the ones we do have and then flip it, and that gets annoying. So we're going to just stick with sine, cosine, and tangent, because that will do everything that we need. All right, so let's take a look at our first problem. So this one, they've really written it out like in sentences. So they can give you a problem like that. Or I could give you a problem like that. Just say alpha equals this, a equals this, solve. And this one's a little bit more written out. So it says one angle of a right triangle is 37, and the hypotenuse is 8. Solve. Now, they didn't say which angle is 37. They just said one of the angles. So it doesn't matter what you call it. If you call it something different than someone else, you should get all the same numbers if you do it correctly. It's just they may call it, alpha, and you may call it beta. You just have different names. But let's do what I suggested first, which is make a sketch. And in the sketch, I'm only going to put things that were given. If you do the sketch right away, that's all you can do, because you don't know anything else yet. So make the sketch right away. And once we finish the sketch, we're not really going to add anything else to it. So let's put the 37, and I'm going to put it right there. And I'm going to put the 8 here. I really don't have a choice where I put the 8. It says the hypotenuse is 8, so I have to put it there. Now let's give names to all the sides. Let's call this side A, B, C. And what do we usually call the angle across from A? Yeah?
Alpha.
So we're going to call this alpha. And what about the angle that's across from B? Yeah. Beta. Okay, so I've got my diagram. These are the two pieces of information that were given. So let's make a table off to the side. The table is going to have all the sides and all the angles. All right, so we know beta is 37. That was given. We know C is 8. That was given. And I'm going to put a box around everything we need to find. There should always be 3 boxes. 1, 2, 3. You can find anything you want in any order you want. It doesn't matter. I usually do the easy things first. Does anyone think they have an idea what would be pretty quick to find in this one? Eli?
Beta.
Yeah, alpha. Alpha would be pretty quick to find because we know all the angles have to add up to 180. So can you tell me what alpha would be here?
53.
Yep. So we know that the right angle is 90. So that means these other two have to add up to 90. So what plus 37 gives you 90? 53. Now, I'm not going to add that angle to my diagram. I only want to keep this diagram, I want to keep things that I originally knew. Because if I put the 53 in the diagram, I might be tempted to use the 53 to find A or to find B. But why do you think I don't want to use the 53? You can technically use either angle you want, but I would pick the 37 over the 53. It's not because it's smaller. Anybody know why I should stick with the 37? Yeah?
Yeah.
Yes?
You could have made a mistake when doing the 53.
Right, I could have made a mistake finding the 53. And if I did make a mistake and I use that to now find something else, well guess what? Now that's wrong too. So don't use something that you find to find something else, ever. Always go back to the 2 pieces of information that you were given. And I circle them so we remember. All right, so now we have to pick if we want to find A or B. Right? Which one do we want to find next? Well, Tyler? A. So we're going to find A. Why not B? Okay, so we're going to find B. So I'm going to circle that so we remember that's the one we're finding. And I also circled the 2 pieces of information that were given. So when I look at this, I've got 3 things circled. 2 of them should be things I was given. 1 of them should be what I'm trying to find. Now, I need to know the name of this, because my next step is to determine, should I use sine, cosine, or tangent? To do that, I need to figure out the names of the 2 sides that I'm using. What's the name of the side that we've called A because it's right next to the angle. What do we call it? Yep.
That's the adjacent.
This is the adjacent. What do we call the side we've labeled 8? Jake? The hypotenuse. So in order to find A, which is the adjacent, you have to use 8, which is the hypotenuse. What trig function involves adjacent and hypotenuse? Your choices are sine, cosine, or tangent. Yeah. Jake? Yes, cosine. So I'm going to write down cosine of, remember that is not multiplication. This is the argument that you're plugging into the cosine formula. Okay? So now we have to put the number that we're going to plug in. We're plugging in 37. So cosine of my angle equals, Ethan, what side is adjacent?
A.
And what's the hypotenuse?
8.
8. A over 8. A over 8. And now the last step is to solve that equation and get A by itself. All right, so how would we just get the 8 on the other side? Chris?
Multiply both sides by 8.
Multiply both sides by 8. And that is your answer. Now, when you're solving a triangle, like we're doing in the second part, they are going to ask you to round the answer off. So now we want to type that in. I'm going to turn the calculator on. And before I do anything, what should I check? Yep.
Make sure you're in radians.
What mode should I be in?
Oh, wait, no, degree. No radians.
What here would tell you what mode I should be in if you look at that box? Degrees, right? This is 37 with a degree symbol, so we want to make sure we're in degrees. All the problems in the homework and on the test that have these kind of directions will be in degrees. I'm not saying there won't be radians or other things, but these will be degrees. All right, so 8 cosine 37, and let's round that to 3, 6.389. So that's A. Now, I know 2 out of 3 of the sides. Anytime you know 2 out of 3 of the sides, what theorem could you use to find the third side? Jake?
Pythagorean Theorem.
You could use Pythagorean Theorem, but why do you think I'm going to say that it's not the best idea? Yep.
Because you could have made a mistake trying to find out.
Right. Could have made a mistake with A, and even if we didn't make a mistake, that's not an exact answer. That's a rounded answer. So we don't want to use anything that's rounded to try to find something else. But even worse, it could just be wrong. And then now B is wrong. So let's find B the same way. Again, these are the 2 pieces of information I was given. Forget about A. We're done with A. Focus on B. B is the opposite side. So to find B, you're going to be involving the hypotenuse, which was given, and the opposite. What trig function has opposite and hypotenuse in it? And it's not cosine because we already used it. Yep.
Sine.
Sine. So let's find B. And we're going to put the sine of, remember that's not multiplication, the sine of, what number are you taking the sine of? 37. Equals opposite over hypotenuse. B divided by 8. It's exactly the same setup as the last problem. Multiply both sides by 8. And there's your answer. 8 sine 37. Now, before I type it in, a couple things you can kind of check. When you're solving a triangle, the biggest side should always be with the biggest angle, and the smallest side should always be with the smallest angle. So this is going to be the smallest side. So if it comes out bigger than 6.389, that's no good. It's got to come out small. So 8 sine 37, 4.815. Another thing you can check really quick visually is in a triangle, the rule is any two sides added together have to be bigger than the third. So if you add the 6 and the 4, that's 10. Yep. 8 and 4 is 12. Yep. 6 and 8 is 14. Yep, that's bigger. So you could never have a triangle with like sides of 1, 1, and 50. They wouldn't connect. You'd have like a really long side and then two little short ones. It wouldn't make it. So any two sides added together have to be bigger than the third. Okay, and if that was a short answer question, you get partial credit for each one you get right. Questions on that? All right, try. I think I have one more of that type. A little less wordy than the last one. They're not really writing it all out. They're just kind of telling you two pieces of information. Same directions. Solve. All right. Two things we should always set up right away before we even start touching a calculator or doing any math at all. Somebody tell me one thing I should do first. Yep.
A diagram.
Yep. Let's make a diagram. If you want to label your diagram first and then erase labels and fill them in later, you can. If you want to call this A, B, C, alpha, beta. And then just erase whichever ones you have. Alpha is 20. So I'm going to put that down here. A is 12.3. Okay, so I got my diagram, which I'm not really going to add anything else to. I am just going to circle the two things that I was given so I remember to use them. And what's the other thing I want to make next to my diagram? Yeah.
Table.
Yeah, just make a table. This is just giving us a spot to put all our answers in one nice area. Every table is going to look just like that. Until we get to problems where we don't have a 90, but that's not this week. All right, so A is 12.3. Alpha is 20. We don't know beta. We don't know B. And we don't know C. Okay, again, find anything you want in any order you want. Anyone have a thought which one we want to do first? Yes.
Beta.
All right, let's do beta first. Could you tell me what beta is?
Yeah. 70.
70. 70 plus 20 is 90, and 90 plus 90 is 180. So I am 100% sure that beta is right. Should I use it? No, you might think you're right. You may think you're right, all the time when you do a problem. But if you are wrong for some reason and you use it, everything else is going to be wrong. So beta is done. Forget about it. Don't even write it in the diagram, so you're not even tempted to use it. All right, you got beta. All right, now how about B or C? Tyler, which one do you want to do?
C.
What's up with B?
I don't like it.
Fair. All right, so we're going to find C. So to find C, I'm going to circle it so we remember that's the one we're finding. What's the name of side C? And by name, I mean its position to the 20-degree angle. Yep. It's the hypotenuse. And what's the position of the 12.3 side? From the perspective of the 20. Yep.
Opposite.
Opposite. So to find C, we need a trig function that has opposite and hypotenuse. I think we've already used that one today. Opposite and hypotenuse would be, Jake?
Sine.
Sine. So, sine of, fill in your argument. Sarah, what's the angle that I'm using? I'm using the 20 degrees. Again, you can do this in radians exactly the same way, we're just not. Sine of 20 degrees equals, Matt, what's the opposite side?
2.3.
What is it?
2.3.
Oh,
I can, 12, sorry, 12.3.
Yeah, 12.3. And Casey, the hypotenuse? C. So a little bit different than the last one. If you look at the equation there, the variable was on the right-hand side, but it was in the top. Now it's on the right-hand side, but it's in the bottom. Well, that's okay. So the first thing we would want to do is to try to just get rid of this fraction. So what's making that a fraction is this division by C. How do you undo division by C? What would you do? Yeah?
Multiply by C.
Yeah, multiply by C. I'm going to put a box around this just so you remember what we started with. But we are going to multiply both sides by C times C. What that's going to do is cancel these C's out. Now we have 12.3 equals C times the sine of 20 degrees. So at least I don't have a fraction anymore, but I still don't have C by itself. Anybody see what the last step would be to get C by itself? Chris?
Divide by the sine of 20 degrees.
Yeah. Divide each side by the sine of 20 degrees. That would cancel. And you would get sine of 20 on the other side. So look at what you have now. C equals 12.3 divided by the sine of 20. Look at what we ended up with and look at what we started with. Does anybody see kind of like a shortcut for how we could go from here to here without having to do this step in the middle? What does it look like is all that really happened? Yeah.
You just swap this sine of 20 degrees and C.
Yeah, we just swapped the sine of 20 with the C. You can do that whenever you have a problem that has this kind of setup. If you're trying to solve for the variable and you have a fraction in a number, you can always switch what's in the bottom with what's on the other side. So from now on, if that ever comes up, instead of going through this step in the middle, I'm just going to switch the variable with what's on the other side. Okay, and let's type that in. 12.3 divided by sine 20. Not really too much you can mess up typing that in. You don't have to put extra sets of parentheses or really anything like that. So just type it in. And you get 35.963. Now that's a pretty big side, but if you remember, A was 12.3, and it's across from a 20-degree angle. So this side's going to be a lot bigger because it's across from a 90. One thing you can't do, though, is say, oh, wait a minute. If I multiply 20 by 4.5, I get 90. So can I just multiply 12.3 times 4.5? No, it doesn't work that way. Right? Yes, this is bigger than this, so this will be bigger than this, but it's not the same amount bigger. Okay. All right, and we can finish up with B. A couple things we know about B already. It has to be the middle side. So it's between 12 and 35. But it couldn't be too big, like it couldn't be 200, because then these two sides added together wouldn't be bigger. So it can't be more than 40, like 35 plus, or that's basically 36 plus 12, it's like 38. So it can't be bigger than 38. So it's got to be smaller than that. But it's also got to be more than 12. Okay? So it's somewhere between those two numbers. Let's see what it is. Find B. Okay if we do B?
Yeah.
Find B. I'm going to go back to my diagram, and I'm just going to again focus on what was given. That, and that. We haven't labeled B yet. That's the adjacent. So now we're trying to find adjacent, and we're going to use the opposite because it was given. Don't use the hypotenuse. Okay. Opposite and adjacent. What trig function would I use for those two?
I think it's due to interruption.
What did I ask? Oh yeah, opposite and adjacent. Yes. Tangent. All right, so I'm going to set it up. Tangent of something equals something over something. All right, how about Jack? Tangent of what? 20. Equals. Eli, what over what?
Opposite over adjacent.
So 12.3 over B.
Yep.
So we're going to end up with the same kind of thing that happened last time, except now I'm going to use the shortcut. B equals 12.3 stays right where it is. Tangent 20 goes to the bottom. All right, and let's see what we got. 12.3 divided by tangent 20. 33.794. 33.794. Okay, and everything looks good. If you have time, you could check it with Pythagorean Theorem. A squared plus b squared should be close to c squared. We've rounded, so it's not going to be exact. Oops. Okay, any questions on that? All right, so that's this case where they give you one of the angles and a side. Let's look at the second case. Let's see, we did that. So let's do this one. So now we're going to look at the case where you have two sides. It says the hypotenuse and one leg of a triangle measure 12.7 and 6.1. Now they haven't told you which one is which, but you kind of have to know. Is the 12.7 or the 6.1 the hypotenuse? Yeah.
12.7.
It has to be the 12.7. Now, the 6.1 is a leg. Which leg? We don't know. So we can let it be A or we can let it be B. Doesn't matter which leg. All right, so first thing that I should do in this problem. Eli?
Draw it.
Let's draw it out. Okay, see what we got. Okay, I'm going to call this side A, B, and C. So I know that C is 12.7. Now we have to pick what we want the 6.1 to be. Could be either one, A or B. Tyler, do you want it to be A or B? Never mind, I know what you're going to say. Let's let it be A. He doesn't like B. So we got 6.1 for side A and 12.7 for side C. That's all we know. Well, we know that's an A. All right. Next, let's make a table. Alright, so A, 6.1. B, don't know. C, 12.7. Okay, alpha, don't know. Beta, don't know. And of course, the last one is the 90, which we do know. All right. There's something I can find first here using a formula that I didn't want to use before, but I'm okay with using it now. Anybody have a guess what formula I'm thinking we can use now, but we couldn't before? Sarah? Yeah, Pythagorean Theorem is fine now. Why? Why was I so against it before, but I'm okay now? Yep.
Because you have your A and C value.
Yeah, I'm not plugging anything into the formula that wasn't given to me. So it's perfectly fine to use Pythagorean Theorem. So let's do that. And that will give us B. So Matt, can you set that up for me to use Pythagorean Theorem to find B?
6.1 squared plus b squared equals 12.7 squared.
Okay, so not the nicest numbers because we have these decimals, but that's why we have a calculator. So 6.1 squared gives me 37.21 plus b squared. And what's this? 150 something? No, 160. 161.29. All right. Abigail, what would be my next step to get the b squared by itself?
Subtract 37 from 21.
Yep. So subtract 37.21. And that's going to give me minus 37.21, 124.08. Now, we have the same kind of problem that we've seen before. We have a variable that's an argument to a function. Okay, it's the argument to the squaring function. So the only way to get rid of the squaring function is with another function that undoes it. What function undoes squaring? Okay, Chris? Square root. So we're going to use the square root function on the left, and we're going to take the square root function on the right. The square root function cancels the square function. And the answer is the square root of, I can just type in second in the minus sign, because it already has the answer that I just put, 124.08. It's going to give me 11.139. All right. Questions on how I got B? All right. Now, we can do alpha or beta. It doesn't matter. Let's do alpha. So this was given. This was given. And this is what I'm going to try to find. So, what position is the 6.1 in? Sarah? It is opposite, at least from the perspective of alpha. And that's the one we're doing right now. How about the 12.7? That's my, yep, it's my hypotenuse. Okay, so what trig function involves opposite and hypotenuse? Type?
Sine.
Sine. So let's set it up. Find beta. So the sine of something equals something over something. So the sine of, I don't know my angle. That's what I'm trying to find. Sine of beta equals, oops, no, we're doing alpha, right?
Yeah.
Yeah, we're not doing beta. We're going to do beta next. So the sine of alpha is opposite over hypotenuse. 6.1 over 12.7. Now, what's different about this compared to the last two problems? Focusing on like the variable. Yeah?
Well, we don't have a variable.
There's no variable in this?
Well, like, not in like the fraction.
Not in the fraction part. Where is the variable?
In the sine.
It's in the sine function. It's an argument to a function. So what we have here is something a little different. We have an argument inside of a function, and that's what we want the answer to. So we have to get rid of this function. So we have, okay, leave a little bit of room. I'm just going to explain what we have to do now, and then we'll go back and do it. There is a function that cancels out sine. I don't know if we've talked about it or not yet. Does anybody know the name of the function that cancels out sine? It's on the calculator, but I don't think it's a button we've used yet. Yeah?
I don't know the name of it, but is it the sign with like the little one above it?
Yeah, it has the sign with a -1, and that's called inverse sine. Okay, just to cancel out, in this case, we have sine. We have to do that with inverse trig, specifically inverse sine. So these are the three inverse trig functions that we're going to use. And what an inverse trig function does is it cancels out a regular trig function, just like squaring cancels out square rooting. Same idea. It cancels it out. There are two ways you can write an inverse trig function. Kind of the more modern way is to write the trig function with a -1 up higher. Or you can write it as arcsine. That's another name for inverse trig. Arcsine, arccosine, and arctangent. What's a little confusing about the notation with the -1 is you might think that that -1 is a certain kind of number. Anyone have a guess what some people might think the -1 is? Yeah?
Exponent.
An exponent, because it's written up higher. It's not. When you write a trig function and you put a number up higher, specifically a -1 up higher, it's purely a symbol that means inverse. It has nothing to do with raising something to a -1 power at all. But what makes it even more confusing is if you do this, that is an exponent. That does mean to do this. Take the sign and square it. So if you put a number here that's not a -1, it is an exponent. If you put a -1, it's a symbol that means inverse. So remember that. -1 is not an exponent. Any other number? Yes. All right, so let's go back to our problem and look at our equation. We're trying to get rid of sine. The way you say it is you want to take the inverse sine of each side. There's no multiplying anywhere in this whole problem at all. Just like if you had this. You wouldn't say multiply both sides by the square root. That doesn't make sense. You would just say take the square root of both sides. Use the same language here. Take the inverse sine of all of that and take the inverse sine of all of that. You could use parentheses, I just use the bracket. And then inverse sine, regular sine cancels each other out. And there's your answer. The inverse sine of 6.1 divided by 12.7. Now, I don't think I showed you how to do it on the calculator yet, but to do an inverse trig function, you press second. Second, and then the trig function you want, and you'll get a -1. So second sine 6.1 divided by 12.7. So that gives me an angle of 28,706. And that's alpha. Now, if I was running out of time and I had to get this done in the next 10 seconds because the bell was going to ring, the test was done, I would just subtract that from 90 and pray I got it right. Because if you subtract it from 90, that'll make all these add up to 180. But if it's wrong and you use it, then beta would be wrong too. So let's find beta the same way we found alpha. Here's beta. Here's the 6.1. Here's the 12.7. Now, from the perspective of beta, what side is the 12.7 now? Yeah? It's still the hypotenuse. There's no change there. What side is the 6.1? Yep.
Adjacent.
It's now adjacent. If you change the angle you're using, which you have to do in this problem, you have to change the names of the sides. Okay, so now that's adjacent. Adjacent and hypotenuse. Let's see if I can just fit that in right here. What trig function would use adjacent and hypotenuse? Yep. Cosine. So it's pretty much going to be the same setup we just had. Cosine of my angle equals 6.1 over 12.7. In fact, the right-hand side is exactly the same. Except now I'm not going to take the inverse sine of each side. I'm going to take the, yep,
The inverse cosine.
the inverse cosine of each side. So beta is the inverse cosine of 6.1 over 12.7. Now, just to double check my answer, let's take this and let's do 90 minus 28.706. It should come out to 61,294. Let's see. So inverse cosine 6.1 divided by 12.7. 61.294. So since I got the same answer checking it two different ways, I know it has to be right. So I used inverse trig and I added all these angles up and made sure they added up to 180. Perfect. Okay, any question on that side? That's the two-side type. All right, let me see. All right, we talked about all that. That's another two-side type. I don't know if we need to do that one. I don't think so. Okay, you would have to use inverse trig here. Okay, that's anytime that you have two sides to start the problem, you have to use inverse trig. Inverse trig is used to find an angle. That's what it's used for. When you have a problem like this, you don't need inverse trig because they gave you an angle. So you're all set. But if they give you two sides, you have to use inverse trig. It's the only way to solve it. All right, so did that, did that, did that. Let's see. We've got about 3 sides left. Probably going to get to this one and then probably stop right about there. So I'll have a little to finish tomorrow, but not much. So it says find the 6 trig values of the angle theta where 2, 3 is on the terminal side. So let me draw that and kind of show you what they're getting at. So it says the 6 trig values in 2, 3 is on the terminal side. Let me get just a piece of graph paper so you can see what we're doing. So the initial side, remember we talked about where you draw the initial side, that's always on the x-axis. There's your initial side. The terminal side goes right through the point 2, 3. So terminal side, 2, 3. Terminal side is just like that. And I can make it the same color if you want. Any question on that? All right, so now what we want to do is kind of think, I made these a little longer than I needed them, but think about making a triangle right here. Draw that straight down. That's a 90. And that's the angle they're talking about right there. This side's 2. This side is 3. What side am I missing? Yeah?
The hypotenuse?
I'm missing the hypotenuse, but how could I find it?
Pythagorean theorem.
We could just do the Pythagorean theorem. And what's the length of the hypotenuse in that triangle? Eli?
The square root of 13.
Yep, square root of 13. Now they're asking you to find the 6 trig functions of that angle. This is what you did in the homework last night. Find the 6 trig functions of theta. Okay, let's start with the sine. Oh, Casey, what's the sine going to be? Yes, so it would be 3 over the square root of 13, but then you need to fix it. So it would be 3 square root of 13 over 13. Perfect. So there's the sine. What about the cosine? Yeah.
2 square root 13 over 13.
2 square root of 13 over 13. And how about my tangent? Yeah. 3 over 2. My cosecant. What's my cosecant? That's hypotenuse over opposite. Tyler?
The square root of 13 over 3.
Yep. Square root of 13 over 3. My secant is... Yep.
Square root of 13 over 2.
Square root of 13 over 2. And my cotangent is 2/3. Now, look at this one. Let me write that one down again. Sine theta equals 3 root 13 over 13. 3 root 13 over 13. I could have picked any of them, but I picked this one. What could I do on both sides to actually figure out the angle here? Yeah.
Take the inverse sine of both sides.
Take the inverse sine of both sides. Now I could have taken this second equation and done the inverse cosine on both sides. Could have taken this bottom one and done the inverse tangent on both sides. So if we take the inverse sine of 3 square root 13 divided by 13, we get an angle of 56.31. That's the angle. And that's approximate. So all that stuff we were doing in the homework last night, when we practiced writing the sine, the cosine, and the tangent, that's the reason why. You can take any one of those equations, solve it, and figure out the size of the angle. Right. Any questions on those 6 trig functions or how I figured out that angle? Figuring out that angle was actually example 4. Solve for the angle. So we actually just did that right here. So there's 1 or 2 things left to talk about with this angle, and we'll pick up with that tomorrow. But there's not much left. So you might even be able to do all the homework. Let me just double check. You do need a calculator. You don't need a graphing one, but you need a regular calculator. 25 to 32 is okay. 40 to 42 is fine. 45 is good. We're going to hold off on 49 and 53, 57 and 61. So just what's in the box. We'll probably take a look at some of these when we do the notes tomorrow. Like I said, it'll probably be about 20 minutes of notes, 20 minutes of homework, and then you'll have about 40 minutes in class free.